Hello everyone. In this video, we will be demonstrating the Cramer's rule. Let us first discuss the algorithm. Number 1. Convert the equation to matrix. If we are having three equations with three unknown variables, therefore we have three variables and then one constant, or three terms rather and one constant. So if we convert that into a matrix, therefore we will be having a 3 by 4 matrix. Second, find the value of d sub delta using the matrix of all variable terms. What you see here on the screen, written on the whiteboard, here is the d sub delta, which will be critical in finding the values of the variables. D sub delta is simply a matrix composed of the values of x1, x2, x sub 2, and x sub 3 of the three equations. So for example, our first equation is on the first row of x sub 1, x sub 2, x sub 3, and the second row is the second equation, and the third row is for the third equation. So it's a simple step in forming this matrix. Then we will be finding the value of that matrix. And then, let us now form our second, third, and fourth matrices, which are the d of x sub 1, d of x sub 2, and d of x sub 3. These are simply the matrices that will be the numerator for our solution in finding their specific values. So here, as you can see as a reference, d of x sub 1, we are going to look for the value of x sub 1 involving this matrix. So we will just simply change the column where originally the x sub 1 is located into a column for the constant. So this will have a columns c, x sub 2, and x sub 3. The same method applies to other columns. For example, for the x sub 2 rather, we will have the columns x sub 1. Then originally this is a column for the x sub 2. We will be changing that into a column for the constant, and then the third column will be for the x sub 3. It also applies in this matrix. After that, divide the second, third, and fourth matrices by the value of this matrix to get their respective values. For example, finding the value of x sub 1 is d of x sub 1 over the value of the delta. Same applies here. There. After we get the values of these three, it is our final step. Therefore, what the values that we will be arriving after solving at this step will be the solutions for the linear systems of equations. So let's now proceed to our example. We have this problem: 2x sub 1 plus 3x sub 2 plus 6 x sub 3 is equal to 7. 5 x sub 1 plus 4 x sub 2 minus 7 x sub 3 is equal to 25. 4 x sub 1 minus 18 x sub 2 plus 10 x sub 3 is equal to 21. Our first step is to convert this into a matrix. Therefore, we will be having a 3 by 4 matrix. 2, 3, 6, 7, 5, 4. Copy the signs. -7, 25, 4, -18, 10, 21. This matrix is not actually a critical part in solving for the solutions, but this will be our guide in properly substituting the values as we go on into different matrices that we will be forming. This this first column is the x sub 1, second column is the x sub 2, third column is the x sub 3, and then the fourth column is for the constant. Therefore, if we are going to form, for example, the matrix for the x sub 2, therefore we will be using x sub 1 for the first column, this value for the second column, then this for the third. This will only be our guide. So if you are solving with us here on this video, please copy this matrix as our guide. We will now be proceeding in finding the value of the d sub delta. It is said that it is formed by a 3 by 3 matrix. Therefore, the three columns are the variables x sub 1, x sub 2, and x sub 3. So we will copy the values. We could solve this using our manual method, or we could also solve this rather using our calculators. That will be pretty much easier. So you choose your own method, but we must arrive on the value negative 1042. That will be our denominator in the next three solutions that we will be doing. So let's start now. So let me first show you what is our d sub x sub 1. So in the delta, this is the x sub 1, x sub 2, x sub 3. Therefore, we will be changing the first column into the values of the constant. 7, 25, and 21. And then, we will be computing for the value of this matrix, d of x sub 1, which is equal to negative 4,997. So d of x sub 1 is equals to, for the x sub 2, this will be x sub 1 then constant, 2, 5, 4, 7, 25, 21. If we compute this matrix, we will be arriving to an answer of 278. Then moving to the x sub 3, d of x sub 3, this will be 3, 4, negative 18, 7, 25, and 21. Let me just put this the value. We will be arriving to an answer of 311. Let's put some division over there. Then the value for the delta is negative 1042. We will now be finding the values of the roots. I will be erasing this now so we could have more space. X sub 1 is equal to d of x sub 1 over the delta, negative 4997 over negative 1042 is equal to 4.7956 rounded to 4 decimal places. X sub 2 will be having the same formula. or same concept for the formula. 278 over negative 1042. We will be arriving at the answer negative 0.2668. And then, let me just copy here the values. And then, x sub 3, we'll be having 311. If we solve for this value, solve for this fraction, simplify the operation, we will be having negative 0.2985. And these three are our solutions for the linear systems of equations using the method Cramer's rule. And at this point, we have just solved it.